We are. Okay, here's type 3. Alright. Remember we said type 1 is something that gets shot off the top of something and goes over and down? Okay. Type 2 we worked last night. They go up and over. So we've got things separated into the two halves and the x and the y components. And then I told you Friday we would be working type 3 problems, which are kind of a combination of things. They're going to go up and over and down. And so if you think about it from here, if I make the dotted line, that right there looks like a type 2 problem, correct? Something that goes up and comes back down to the same level that it started from. And then in the last unit, we worked free fall problems with things that just fall straight down. That's going to be the bottom half of this. So, okay, here's the first one. You have a cannon that is perched on the edge of a 48-meter high cliff. So if we sketch ourselves a little picture here, we have a 48-meter high cliff, and then we have a little cannon. So here's my cannon, and it aims 30 degrees above the horizontal. Now notice, it doesn't say 30 degrees above the ground because the ground is 48 meters below. So we have a cannon that's getting ready to shoot a cannonball out above like the ground level. We're on a cliff. So it's going to fire it at 52 meters per second. And I'm kind of out of room in order to draw it, but it's going to go 52 meters per second on the horizontal, like not on the horizontal, sorry, but on the angle. So it's going to go through my words and up and over and down. Okay. It wants to know how long it takes it for the shell to hit the ground, and then it wants to know how far it lands from the base of the cliff. So for sure, one of the things that I'm trying to find is this delta x right here. How far out does it go? Okay, same thing we've been doing. We've been making an XY chart, right? What are the three things that I can find about the x again? About the x. About the horizontal. There were three things. Velocity, distance, and time. V, delta x, and t. There are five things that I can find for the y. Acceleration, time, initial and final velocities, and distance. Very good. Okay, let's figure out what numbers I have. I know my y acceleration is what? Negative 9.8 meters per second squared. Okay, I don't know time. I can figure out my velocities. One of the two velocities I do know. For which one?
Initial, because you are starting at the cannon.
Nope, not how we've been doing it. Final is 0. Tell Josh why.
Because it hits the ground, like it stops on the ground.
No, I don't like that explanation either. Yeah, we're breaking it up. We're breaking it up into the triangle. Like that my pathway at its highest point up here, when it goes up, it technically stops and then it comes back down. That's a horrible parabola, sorry. So it's going to start out with some vertical speed, and it's going to slow down as gravity works against it till it works its way up to the top of the parabola, at which point its vertical velocity will be 0. And then it comes back down, and gravity will actually speed it back up as it pulls it towards the ground, and it will hit the ground at the same exact speed that it was shot off of the ground.
So the initial is always at that highest point for these type of projectile problems?
The initial is always at its starting. Starting and coming back to the same level.
That's when it makes the biggest.
Your initial is when it makes the biggest, it's going the fastest.
Think about when I toss the balloons up. If I pick the balloons up right here and I toss them up in the air, I throw them up with a speed, and technically in order for them to stop and come back down, they have to stop. They must have a velocity of 0 at the highest point before they turn around and come back down.
Think about it as like a gun shooting. You know how it starts off really fast.
I mean, ultimately, it's got to slow down.
It stops. Or like if you shoot something straight up.
If you shot a gun straight up in the air, number one, that'd be super stupid because it's going to come right back down and hit you. But in order for it to come back down, somewhere along the way, it's got to stop and basically turn around and come back. If it doesn't reach 0 at some point, then it's just going to keep going and going and going and going and going and going and going forever. And you know it doesn't do that.
Technically it wouldn't hit you if there's a
Well, but we're assuming none. So now, alright, so from this, if I put my numbers back into this triangle, we just did these. If it's going 52 meters per second right here, I can find my vertical component of the velocity, and I just said vertical, my horizontal and my vertical, my Vx and my Vy, using our good old friends sine and cosine. So if I'm going to need that here in order to figure out the time. Okay, so I'm going to go ahead and I'm going to do the cosine of 30 degrees, and I'm going to have to do the sine of 30 degrees. If I do cosine, that's adjacent, so that'll be Vx over 52 meters per second. We're just using trig to find our vertical and horizontal velocities. Sine will be for Vy. Okay. So if I stop there and I do the cosine of 30, cosine of 30 times 52, we end up with a Vx of 45 meters per second. Which I'm going to store in case I want it later. And then if I do the sine of 30 times 52, I get exactly 26. Isn't that lovely? No storing necessary. Like, it rounds perfectly. Now, unfortunately, that didn't answer any questions for me whatsoever. Like, that still has not addressed A, and it hadn't answered B. But I'm getting on my way, because what this tells me is that it initially has a vertical velocity of 26 meters per second. And if I know that, I know 3 of my pieces. Do I have enough to solve for something? I'm not concerned, though, with how high it goes up in the air, so there's really no point in me solving delta x. It asks me for how long it takes to hit the ground, so I'm more concerned with working t. So if I want to move on to kind of the next stage, if I work A is equal to delta V over T, and I plug things in there, I've got negative 9.8 meters per second squared is equal to 0 minus 26 divided by time. I'll be able to solve for time. And I'll have 26 divided by 9.8. I end up with a time of 2.65 and some more seconds. But what do we know about that time, y'all?
We need it.
What else about it, though?
Oh, that's only half of it because you're only going.
Okay, and that's only half of it, so I need to multiply it by 2, because that's the amount of time that it took it to make it to the top of the parabola, to the apogee. It's still got to come back down. So if I take that and multiply it by 2, I get 5.306122449. Now, the question is, if this little cannon shot the shell at ground level and it came back to ground level, I would be done with my problem. But instead, the stupid little cannon is perched at the edge of a cliff to make my life more miserable. So what I have now found is that it's going to take this precious shell, it's going to take it 5.3 seconds to fall to the red line. That's what I just found. It's fallen back to where it started from. So I need to do one more thing in order to have me a final answer for A. I then need to figure out how long it takes it to fall from 48 meters down. We've already done these in Unit 2. It just becomes a free fall problem. Does that kind of make sense? Except it's not exactly free fall anymore.
Is that where the person was dropping the ball?
Yes, where the person was dropping the ball. But there is a slight twist here, because is the person just simply letting go of the shell at that point?
No, like it's going up 2 meters.
So instead of it having an initial velocity this time of 0,
Its initial velocity is just 2 meters per second.
no. What is its vertical velocity? We just found that. What is its vertical velocity at that point?
Uh,
26. When it reaches this point right here, it now has a velocity of 28 meters per second. So this time, instead of it, did I say 26? What did I say?
28. Is that
26. Sorry. It's got a vertical velocity of 26 meters per second. So, I mean, I can go back up here. I'll do it in red just to add stuff back into it. But what I know right here is that from that point down, it's already going 26 meters per second. Right there. I still know that acceleration at this point is still 9.8 meters per second squared, right? Is that true? Is it pulling it down? Is it going to be positive or negative? We worked at negative going up. Why? What is the speed doing as it goes up? As it goes up? In a positive manner or a negative manner? It's slowing down, so we're going to represent that with negative 9.8. What should an object be doing as it falls down towards the ground? Speeding up. So we need to call it a positive 9.8 meters per second. And I know this, too. I know that the distance that it falls is 48 meters. So I know VI, I know A, and I know X. Do you have any equations that would possibly help you figure out, like if you look through here, do I have any equations where I could use delta X, VI, and any of those things in order to help me?
You already have all of those, but so you're just trying to figure out the time, aren't you?
Do I need time?
So
Yeah.
it would be the one that's written in pen.
The one, well, and why did I write that one in pen?
Oh, it's very, very important.
You went ahead and moved over
It's just the same of what you have up there.
I did. I went ahead and subtracted this X from that side so that it was X sub F is equal to minus X sub I is equal to that. Just, to me, that just seems easier. Because seldom do we work it with two X's. We usually work it where we've just been given delta X. So I just rearranged it. I just wrote it a different way. Not because it's very, very important, but just because I wanted to write it differently. Okay, so now this is where, if I get the time, I'll see if I can go back and just rework this without asking questions, because we could probably already be done, but in the meantime, you get to listen to them. Maybe that's helpful to hear the questions asked again. So the question is now, maybe I'll write in this little space right here. I know a couple different things that may or may not help me. I know I'm looking for T. I'm looking for T for this section, correct? We know that we have this one, that delta X is equal to VIT plus 1/2 AT squared. Have any issues with that one? There's not 3 T's, but T is in two different places. That just seems yucky, doesn't it? Does that seem evil? What else do we have? Where to go? Alright. I know too that I have this one as you plot your course. Want to find any fault with that one? Hmm? What do you think?
Actually, no.
Huh?
Uh,
If you want to break it down.
That would be pretty much exactly what you just got though.
But I need to do it for this. I now need to work it for this part of the problem, not just over here. Like I've already figured out from here. Now I need to go from the red line down. So what I'm asking you basically is do you find any fault with this? And here's part of why I'm doing this is when y'all work these from home and you work them at night, do you need to take into account the kinds of things that I'm doing right now? And I don't think some of you are. I don't think you're thinking through the problems. I think you're just simply going, I don't know, like there's my picture, there's X, Y, I quit. Well, find the fault with this one. I have a problem with using this. I want you to find the fault for me.
you don't have to.
It's the exact answer we just got about being multiplied. So it's 50.65.
I don't have enough stuff to find it. I can't do it from here down.
You have a velocity and acceleration.
I only have one of those two velocities.
One is one of zero.
No, it's not. No, it's not. My VI is 26. You're telling me it's going to stop before it hits the ground? Or should it not be hitting the ground even faster than 26 meters per second? Maybe we need a better understanding of the problem. So, is it not going to speed up as it goes from here down? Because it's accelerating. So, it will not hit the ground at 0. It's going to hit the ground even faster than 26 meters per second. Right? Okay. My other thing that I have to work with at the moment is do what? Well, if I'm going to use this one now, I'm going to have to find the final, yes.
116.8. Oh, no, 16.8.
Do I have enough to do this? V squared is equal to VI squared plus 2A delta X. Do I have VI? Do I have A?
Yeah.
Do I have X?
Yes.
Holy crap.
So it'd be 40 actually. I forgot.
So then, but look, is this not what y'all need to do on your own? Do you not need to be thinking through the different formulas like this so that you can figure out, like, no, that one's not going to work. No, I'm missing that. I could use this to find T, but I'm missing VF. Oh, holy crap. Here, I could find VF. Like, doesn't this stink to do this many problems? Yeah, kind of. So, okay, so I can do this one. Winner, winner, chicken dinner. Here is one that will work. So, I could find VF. What's my VI for just the red part of the problem? Not meters per second squared, but just meters per second. Where's my white out? Okay. My bad. Okay.
Did you just add what you get there to the bottom of the three?
Hang on. Times 9.8. And then 48. Have you already done this? Montana's working ahead. So 2 times 9.8 times 48, the square root of all that good stuff. So yes, I get 40.20 blah 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 meters per second. That means that that cannon shell is going to be hitting the ground at 40 meters per second. Should make good sense. It started out at 26, it ended up at 26, but then it's going to fall down now so it can pick up even more speed. It's not going to reach terminal velocity yet. So it hits the ground at 40. Okay? So, now, if I know it's VF, can I go back now and plug that into A is equal to delta V over T?
Yeah.
So I've got 9.8, yep, 9.8 meters per second squared is going to be equal to the 40.209 number that's in my calculator still, minus 26 over T. And then we can go with Montana, who's working ahead of us. What'd you get? 1.4499 seconds. Okay. Alright. Then yes, add the 1.4499 to the 5.306122449 plus 5.306, and you're going to get 6.75. Well, it's 1.4 plus 5.3. I'm going to round it to 2 sig figs and call it 6.8 seconds. So it takes it 6.8 seconds to fall. All the way down to the ground. Boom. Because I took the type 2 piece and I took the fall piece and I added them together. The last piece should actually be easy. The last part of the question wants to know how far out did it go. And so I guess you could laugh since I'm saying that it should be easy, but the part about the dx should actually be fairly simple.
Regardless, just from what the base of type 2 is then.
Yeah, kind of going back to like it was before.
'Cause
Does it go any further out once it reaches the red line? Does it stop its horizontal movement at that point? So actually, you're going to find B just like you did with the type 2 problems. What equation do I need? So here's my answer.
So all that work was just for A?
Yeah. Welcome to physics. So I'm going back to like we were doing before, that V is equal to delta X over T. What is my vertical, no, I mean, that's not my vertical. What's my horizontal speed? Yep. Back up here was 45. My delta X is what I'm going to find. Now, I still have to go back and think. It took 5.3 seconds to come down to the red line.
You gotta use the 2.65.
And then it took me one,
Yeah.
do what now? I'm concerned with how much time it took it up here above the red line.
Oh, so you do use the 5.3.
I'm going to use the 5.3. And if you don't want to store numbers, then you put as many of them as you can in your calculator. And you write as many of them down. What'd you get? Okay, that's not what I thought you said. So my delta X is going to be, I'm looking back at all of the sig figs that we've got up there, 240 meters. Everything has had 2. So 240 meters. Yeah, that was short. It's going to be the time component that's going to take you the piece. Okay. That leaves me with basically wanting to work another one of these for you tomorrow rather than just have you like attempt those tonight. So what I want you to do tonight is I want you to go back to those other 4 problems. I'll give you free range here. If you would like to go ahead and try the type 3 problems, then yes, you have a couple more on your homework, that you could go ahead and try, because I think there's a couple of you who could do this. And then those of you who are stuck on the type 2, go ahead and work type 2. Go ahead and work a type 2 style problem. You know what I mean? Like, go back and work those other 4 that we did here, like 7, 8, 9, and 10. And then tomorrow, what we're going to have time to do is just kind of work whatever you need to work and get help with it before we move on. Okay? I can figure out how to stop the recording, I'll put it up on,
If only I was in next hour in high school.
do what?
Only I was out